Hey everybody, welcome to another video. Today we're going to be working on this Xbox Series X. This has been sent in by a customer because it's got no power. So the customer originally bought some parts from my online store and unfortunately they weren't the parts that he needed, so he sent them back along with the parts that he ordered. Obviously he ordered some, well I say obviously, it's not obvious, but he ordered some MOSFETs for the Xbox Series X, and once he's installed those he still had the same issue with no power. I think he basically just tried his luck with the MOSFETs, and basically once he'd tried that, he noticed some issues with one of the inductors, the R15 inductors just above the MOSFETs, and apparently there's been a prior repair attempt on it, so he sent it over to me to try and figure it out for him rather than sinking money into parts which he might not need. So with that being said, my name is Lakota. I'm an electronics technician. I mainly work on games consoles, but I do work on other stuff as well. So if that's the sort of stuff you're into, be sure to get subscribed and turn the bell notifications, and that way you don't miss any future videos. If you do want to organise a repair, you can get in touch at lakota.repair. The coder is spelled the same way as on YouTube, so just head over to the website. You can send me an email, you can request a quote, or you can just send over the device for me to repair for you. I do normally give a price in the videos of what it's going to cost the customer if I'm able to repair it. I do work no fix no fee, and a lot of the time, even when it's a prior repair attempt, as long as the customer's honest, I generally don't tend to charge a fee. It really depends on what I've got to do to it, obviously. If there's a prior repair attempt, I have to take it case by case, but obviously if it's just something like a broken inductor or something, then I'm not going to charge a repair attempt fee for that if I'm unable to repair it. So with that being said, let's get into today's video. Today's video is sponsored by PCBWay. Whether you've got a simple project that requires a quick mod board or you want to launch your own products to the world, PCBWay can help. With fantastic pricing on multi-layer PCBs, flex PCBs, 3D printing and even laser cutting solutions, you're sure to get everything you need all in one place. Custom PCBs start from just $5 for a 1 to 2 layer board with a fast 24-hour build time and free shipping on orders over $30. PCBWay are also proud to announce their new aluminium PCBs, which start at just $120 per square metre. Check out what PCBWay have to offer by clicking on the link in the video description or the top pinned comment and get your project started today. Thanks again to PCBWay for sponsoring the video. Let's get back to the repair. Alright, so I'm going to struggle a little bit to read this because, well, to be honest, I mean, yes, I am pretty articulate and I can read very, very well, but handwriting, I just never seem to be able to read properly. So I'll try, but yeah. So it says, I purchased this as not working. I was informed that it just wouldn't turn on. Assuming it might be a dead capacitor, I changed one of the caps by the MOSFETs. You'll know which one. It was difficult to resolder as the board takes a lot of heat. Yes, that is very, very true. No difference. So I purchased new MOSFETs from you. I've got those in a envelope just here. So I replaced U55. Again, it took an enormous amount of heat and flux, so it was quite difficult. Surrounding capacitors were still shorting, so I checked the rest of the board, and then I saw the huge trace repair near the R15 coils beside R241. I have no other reference motherboard, so I have no idea where to even start on reverse engineering the issue. In summary, repair work I carried out: a single SMD cap and a MOSFET. Previous repair attempt discovered blown track. Okay. I have included the MOSFETs I purchased from you in my delivery. One of them is encased in white masking tape. That is the one I removed. I have no need for them anymore. Fair enough. Okay, so basically the TLDR here is obviously that it doesn't work, etc, etc. That's just saying the same thing. They just got a burnt trace and stuff. So yeah, the TLDR is that he's replaced a capacitor and I don't think he needs the MOSFETs. So here's what I'll do. So for example, in fact I'll go to Facecam for this because this is quite important. So here's what I'll do. So if the issue is down to the MOSFETs, then obviously the first thing I'm going to do is use the MOSFETs that are supplied to the customer. I supplied 2 MOSFETs by the look of it. Let's have a look. So here's the order sheet. Yeah, pack of 2 MOSFETs. I actually remember this order. It's in one of these envelopes because it went to Ireland, so obviously it's cheaper for me to post if it's in one of these cardboard backed envelopes. So here's what I'll do. If it is down to a MOSFET, I'll use the customer's MOSFETs first, the MOSFETs that I sent to the customer, because that will save the customer money. So let's say, for example, I get an issue where I've got to replace 1 to 2 MOSFETs. I'm going to charge around about £60 labour for that, plus the cost of the parts. So if I've got to change 1, then I'll charge £10 extra, so it'd be like £70. If I've got to change 2, then it'd be £80. You get the idea, right? So if I can use the MOSFETs that the customer's already paid for, then obviously I'll use those. If, for example, the issue isn't down to the MOSFETs, I might give a little discount based on the fact that the customer's ordered some MOSFETs from me. I wouldn't give a full discount because, I mean, at the end of the day, I sell parts. I don't diagnose the fault for the customer if they're ordering from me. So I might give a little bit of a discount depending on what the actual cost is going to be and whether I can, you know, have any wiggle room and stuff like that. Because the bottom line is I've still taken time to obviously, you know, package these up and stuff like that and post them out and, you know, remove them from donor boards, test them, etc, etc. So at the end of the day, there's still some time gone into it, right? So yeah, I'll do what I can to save the customer money, but obviously I can only do so much because at the end of the day, I still have to make money. I still run a business, and obviously time is money, right? Time is the most valuable asset that you're ever going to have. There is no replacing it. It's the most valuable and it is the most scarce because once it's gone, it's gone. Getting a little bit philosophical for a repair video here, but yeah, there you go. That's the bottom line. So I'll do what I can. Let's get this, well, let's power it on first and see if it actually does turn on. I do want to verify the issue before I go any further. But if you do need any parts and stuff, consolefix.shop, super fast delivery. And they do work as well, which I'll prove if I need to use these ones. But yeah, there you go. So let's have a look, shall we? What is the deal with this? So, completely no power. Cool. Okay, I like no power because no power are generally a little bit easier to diagnose. So, yeah, we'll see. Okay, so the first thing I want to mention is that this connector here is broken. So on the Xbox Series X, you've got 2 boards, and they're both connected to each other with this 80-pin connector or 81-pin connector. So I think it's 80 actually. So basically, to remove these, you're meant to squeeze these 2 buttons together, these 2 clips, right? This clip here is broken. So it may cause an issue, but it wouldn't cause an issue to the point where it wouldn't turn on at all. If anything, it will cause a beep on, beep off. I don't think it will, but it may. So we need to bear that in mind if we can't get this working, because obviously we'd need to replace this connector if it does end up beep on, beep off. Or that would be the first place I look for an issue. So yes, the first step for me is obviously going to be just to test the power supply. So regardless of what the customer says, and this is nothing against the customer, obviously, but regardless of what the customer says, I always test the power supply before I do anything when we've got a complete no power. Even if we've got a beep on, beep off, I still generally tend to test the power supply. Even though if we've got a beep on, beep off, 99% of the time, you know, you're going to get like one in, probably less, more than 99% of the time, you're going to get like 1 in less than 200 where a power supply is going to cause beep on, beep off. It's really not going to be that, you know, that common for that to happen. So yeah, but I'll still test the power supply anyway, because we could sit there going down a rabbit hole trying to fault find a no power issue and it just turned out to be a power supply issue. So yeah, let's test that first. So I've got my multimeter in DC volts, and I'm just going to check by testing here and here. We get 11.78 volts. That's absolutely fine. So between 11.7 and 12.2 is generally fine. You're going to get you're going to get the console to turn on with that. That's absolutely fine. It never puts out an exact 12 volts. Okay, so we know the power supply is good. So the next step for me then is going to be to go into continuity mode and just double check and make sure we don't have a short on the Southbridge board. So I can do that just by testing these 2 pins here. And I'll zoom in so you can see that. So we've got the connector here, and on the back of that connector you've got 2 pins. Just check those 2 pins, and that is not short to ground, or rather they're not short to each other. So this right hand one here is going to be ground, so it's going to be 12 volts. So if we check that to ground, we see we've got no short. If we check the other one, that one is, because that one is a ground pin. So there shouldn't be anything wrong with the Southbridge board, so we can forget about that. What you could do is you could plug in the Southbridge board to the power supply, plug your Nexus ribbon in and just press the power button. Okay, so we do see some damage down here. I'm going to inspect this around here first though. Alright, so what is this here? What are we dealing with here? I honestly do not know what that is. I think that could be flux. Alright. Cool. I'll clean that up later on. But this isn't good as well. The fact that this connector is stuck in here. It's not great. That feels like it's glued in to me. So yeah, it stands a chance that we could end up having to replace that connector, right? You know, if that's glued in but it's not actually making a contact on some of the pins, we're kind of screwed. And it's not glued in, but it is wedged in. Ah, there we go. Okay. Oh, so I managed to get that out. I'm not seeing any damage in there. Bit of gunk though. Not good. Alright, never mind. Let's forget about that for now, right? Let's just inspect the rest of this board. So I'm looking to see if there's any damage, considering we've got prior repair attempts, not just by the customer but by someone else previously as well. I'm looking for any damage, any signs of rework. I know there's some rework around the other side by the other MOSFETs. I'm aware of that. But I just want to inspect everything else first. Okay, we've got a capacitor there. I'm assuming... well, that could have been the customer. Okay, that is not good at all. We've got some obvious damage around here. This has taken a whack. Not as in drop, I mean it's taken a whack as in electrically. This is not good. Oh wow, okay, well, yeah, that's going to have internally shorted layers, I'm assuming. That's bad. That is not good at all. Might have to do a little bit of digging. See, this is why we do a visual inspection. Oh, okay, well. Yeah, this board might be too far gone. Okay, well, I'm assuming we've got 12 volts short. Let's just check. Yeah, dead short on 12 volt. Okay, so if there's one thing that I can recommend anyone get, I mean, even if you're not a technician, get one of these. A thermal camera. If you are able to, if your finances allow for it, get yourself a thermal camera, because not only is it handy for things like the house, for finding hotspots and stuff in the walls, it's also handy for finding shorts on a board. So what I'm going to do is I'm going to hook up my thermal camera and I'm going to inject some voltage into the 12 volt rail. So what that means is I'm going to take one of these bench power supplies just here, and I'm going to set it at 1 volt, and I'm going to force 1 volt through the 12 volt rail. Now, even though the rail is a 12 volt rail, what it's going to do is that's going to force that power. Because see, here's the thing, let me try and explain this. When you have a short on the 12 volt power supply, on the power supply itself, so when you have a short on the 12 volt rail, that causes the power supply to shut itself off to protect it from obviously causing fires and to protect the components from being damaged, etc, etc. So if we was to just apply 12 volts from the power supply, nothing's going to happen. All he's going to do is he's going to put the power supply into protection mode until the capacitors get drained, which means unplugging it, leaving it off for a few seconds, you know, like 10 to 20 seconds or something, and then turning it back on. And then if you plug it back in, it's going to obviously do the same again. So it's just going to keep putting itself into protection mode, which is why we're getting no power. It's not attempting to turn on. Now, if we force power through this board, that's going to, well, basically this isn't going to go into protection mode. It's going to force that power through. And electricity, in the simplest term, is lazy. So what it's going to do is it's going to find the path with the least resistance. And the path with the least resistance is going to be whatever component is short, because that's going to have a 0 ohm resistance to ground. So it's going to try and flow through that component. It's going to force a load of current through that component, and it's going to push it all down to ground. So obviously the console's still not going to turn on, but by forcing the current through that component should, in theory, get hot. It obviously depends on what the component is designed to handle, but in theory, that one component where all of that electricity is flowing through is going to get hot, and the thermal camera is going to pick it up like a sore thumb. So the thermal camera is very, very handy for short detection on a component or on you know, a circuit board and things like that. It's also handy for other things, you know, like checking to see if components are actually turning on when they're supposed to. I do that quite often on PlayStation 4s, I've done it on PlayStation 5s, I've done it on Xboxes when the RAM has failed, etc. So yeah, I'm going to use my thermal camera when I actually find it. I know I've got it, it's plugged in just here, so there it is. So the thermal camera I've got is a very, very tiny thermal camera. This isn't sponsored, although I did receive this for free, and I've just realised my hair is a mess. I can see it in the reflection. You know what? I don't care. So yeah, this is a Infrared P2 Pro. This isn't sponsored, but I did receive this for free when I first got it. Infrared sent me this to review, and honestly, I've loved it ever since. It is so much better than things like the Flirt and stuff like that. The resolution and response time on this is absolutely second to none. For the price point, I don't think you're really going to find better. I do have affiliate links to this. Every time someone buys something through my affiliate links, I obviously give a little bit of a kickback. So it does help the channel and stuff like that. It helps me to keep these videos free and stuff. But honestly, if you're going to get a thermal camera, I really do recommend checking this out. I do have a video on the channel where you can check out the review that I did on this when I first received it. But yeah, this is what I'm going to use, the Infrared P2 Pro. Not sponsored this time, but it is an absolutely fantastic bit of kit. Highly recommend you getting one, even if you don't do repairs full time. One of the good things about the Infrared P2 Pro, as you can see, a black screen has just come up on the corner. One of the good things about the Infrared P2 Pro is that the PC software for the TC camera, so TC View the software is called, works for the Infrared P2 Pro. So obviously you can see the response time here. There's going to be a little bit of input delay, you know, a few milliseconds and stuff, but honestly, it's absolutely fantastic. It's going to pick up heat. Just like that, look. See how hot I am? Yeah, you know it. Anyway, a little bit of a lag sometimes, but, you know, the software is not designed for this thermal camera, but it does work, and it works well. But anyway, I am going to get the bench supply set up here. So if we just pop in the bench supply cables, I'm going to inject 1 volt. So I'm going to set my bench power supply to 1 volt. And I'm going to, well, actually, I'm going to use a crocodile clip so I can free up a hand to use the thermal camera. So I'll use a crocodile clip for ground. Just like this, and then I'm going to inject 1 volt just like this. So we've got 5 amps of current. I might actually be injecting on the wrong side. I can't actually remember which side 12 volts is, I'm going to be honest. It is the backside. Okay, I thought it was. Yeah. Okay, so I'm going to inject 12 volts, 1 volt into this. So we get a voltage drop of 0.2 volts. We get 5 amps of current draw, so that's drawing 4 watts. I don't think that's going to be enough to show up any hotspots, I'll be honest. Is there any short here? No. Yeah, so I don't think that's going to be enough to show any kind of heat spot. So let's go to 2 volts then. No, we're still getting voltage drop. It's still dropping down to 0.74 volts. So yeah, the thermal camera is not going to help us right now. So what I'm going to have to do then is I'm going to have to isolate the APU and the other components. So what I need to do is remove these inductors here and these inductors here. And the reason for that is because while the inductors are there, the power is able to travel through this circuit and into the other components, and that stops it from heating up. So I'm just going to get all of these R15 components here and these R15 components here. They're inductors. I'm going to get all of those removed so as I can, well, basically fault find a little bit better. I'm going to fast forward through this. It's going to take me a little while to do. Okay, so I've just removed all the inductors. I've retinned all of the pads ready, but what I'm going to do as well is just get rid of all of this viscous paste around here because I need to see underneath here. It's a little bit difficult to get rid of this viscous paste, but I need to get rid of it because I basically need to see what's going on. We could have more components which are damaged, and also the viscous paste is going to stop the, well, it's not going to stop it completely, but it would affect the readings I'm getting on the thermal camera. So I'm just going to get all of this removed because I'm still waiting for the board to cool down anyway. Alright, as you can see, that's made a hell of a mess on my bench. What's that? Don't know where that MOSFET's come from. Actually, yes, I do. It's off a laptop I was working on yesterday, never mind. Right, so hell of a mess on the desk, but it's one of those things that just has to be done, unfortunately. It's not a very pleasant thing to have to do, but it is what it is. Okay, I think we're good there. Let's just dry off the IPA. So the reason I'm drying the IPA off isn't because it affects the board, it's because I've actually had a motherboard catch fire because there was IPA on the board and I injected voltage. One spark and the board went up along with my table. So yeah, never inject voltage while you've got IPA on the board. You can drop IPA on it once the voltage is actually being injected. But if you've got IPA on the board, just don't inject voltage, because if you get one spark, it's going to cause a fire. IPA is incredibly flammable. Thermal cam back on. We've got all of these inductors removed. Yes, there are quite a few there. We've got, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 inductors we have to remove just to isolate this 12 volt supply. So that's always fun. Not. Anyway. Now what do we get? Still no hot spots. Still have a little bit of heat in the board. I may need to remove the MOSFETs. Oh, here we go. There. Right, let's pop on the macro lens. Now I'm seeing it from this side of the board. Yes, right there. This group of components just here. So that heat spot corresponds to these two capacitors right here, which I actually spotted earlier on, but I didn't remove them. So we have some burning here. I'm going to remove all three of those components, and then let's just pop a little bit of flux on here, just a tad, because what I'm going to do is I'm just going to wick all of this away so it's nice and flat, and then that way I can see what's actually going on. So if I just add some solder here, just like that, there we are, and then take some solder braid. So we can clearly see we've got damage here now that I've added solder. I can feel damage as well. But what this is going to do is it's going to basically, well, the wick is going to act as an abrasive, and it's going to clean up a little bit of this burnt PCB. It's going to get rid of a little bit of the charring. It looks like we might have a hole in the board just here. Okay, there we are. So let's just see if the short is still here. Yes. So can you see that isopropyl alcohol evaporating? So if I just pop some more IPA on there, you'll see we get some heat right there. Right there. So we've got either damage on the other side of this board. I mean, that's quite hot actually. Yeah, it's uncomfortable to touch. It's not above 100 degrees Celsius. It's uncomfortable to touch, but it's not, you know, super hot. So it's around about 45 degrees Celsius. So that area just here corresponds to this damage around here, right? So what I'm going to need to do is basically get rid of all of this work, what's been done here. I can't really leave it. Let's just inject voltage again. Okay, I don't think the damage is on this side. So I'm not seeing any kind of heat signs on this side of the board. If I add, I mean, it is evaporating, right? But it's not evaporating from this side of the board by the look of it. It looks like someone's already dug a little bit around here. So I'm probably going to have to clean this up and dig some more. Because I don't know, well, I mean, I'll see if I can clear the short from the other side. But we've definitely got a short here, and I think it's probably going to be an internal short. I can see some of the PCBs protruding there, so I'm going to say it's probably going to be an internal short. So I'm going to get a little grinding pen. I'm going to just do a little bit of dental work. Okay, we've definitely got some char in there. So there is 100% an internal short here. Here's what I am going to do. While I'm actually working on this, I'm going to keep the voltage going. It's only 1 volt and it's not going to hurt to keep it going. In fact, I've already gone down to 2.7 amps there. 2.8 amps. So we've 100% got a short. There we go, that's it, it's done. Short's gone. I've just ground it away. We no longer have a short. Oh, sorry, no, we do. Never mind, it's a contact issue. Well, ignore what I just said then. We do have a short still.
For the first time in ages, I wake up and don't hate it. I guess I found some peace. Through the day to the evening, without shouting and screaming, something new to me. Alone without being lonely, getting back to the old me. It's kinda nice to feel free. I thought this was over, thought I could control it. But if I speak the truth, I ain't over you. I was feeling sober until you came up now. I don't know what to do. I ain't over you. I ain't over. I ain't over. No matter what I do, I ain't over you. Give it time, things will settle. Just a face till it's better, yeah. Heard it all before. Even though we were toxic, feels the most when you've lost it. That's just how it goes. By myself feeling lonely, can't get back to the old me. I'm stuck in way too deep. I thought this was over, thought I could control it. But if I speak the truth, I ain't over you. I was feeling sober until you came up now. I don't know what to do. I ain't over you. I ain't over. I ain't over. No matter what I do, I ain't over you. I ain't over. I ain't over. No matter what I do, I ain't over you. Ain't over you. Ain't over you. And no matter what I do, I ain't over you.
I can see through the board, and I still can't see that short disappearing. Yeah, I just got intrigued as to how far that short goes, but it looks like this goes way beyond the ability to repair it. Some of the time you can drill a hole through the board, exactly what I've done here. That's a clean hole. There's no, I can't see any shorts, you know, in between the layers in that hole. And sometimes you can do that and clear the short and it'll work, because there's a lot more, you know, MOSFETs on the phase, and it doesn't need all of them to work, right? As long as the path is still there and it's still complete, it's able to actually, you know, allow current to pass and stuff, it would actually work. The only way to get this console working, realistically, is to take this APU off this board and put it onto a donor board, which I don't think the customer's going to want to do. That's the problem. So, yeah, this board is absolutely junk. There's no saving this board at all. Like I said, it is possible to save the APU if it isn't dead. This took a hell of a whack. It took a hell of a whack. I do have a BGA machine. I have got the ability to actually take the APU off this and put it onto a donor board. The problem I've got is the customer going to want to pay for it? Because that's a big job. It means lifting this off. That machine is, I think, about 2,000 watts. It's like running an oven. It's expensive to run, so I have to charge accordingly. Not only that, it takes a lot of flux, it takes a lot of time, and it takes a lot of effort to remove the APU, and I'm going to cover the cost of an actual board as well. Honestly, I don't think it's worth it. So I think I'm going to give the customer two options. I'm going to offer to buy it, albeit not for very much. I would probably give like £50 or £60 for this, maximum. It's really not worth a lot. And then I'll just pull the APU off, take the risk, and see if I can save it and get it working by swapping the APU board. Or I can offer to actually do the repair, but you're looking at about £200. It's really not worth it. And by the way, that's still less than what Microsoft would charge for an out-of-warranty repair. But it's really not worth it. The problem is you can buy a fully working console for about £300 with a warranty. So is the customer going to want to pay that? Probably not. But I've got to give the customer the option. There is a repair path for this, but it's whether or not the customer actually wants to go down that path. There is a hell of a short inside this board, and there's no saving it, unfortunately. So I got a little bit carried away with that. I did get a little bit curious as to how far that short goes, but I just can't determine it. So with that being said, that's going to be it for this video. It's going to be a no fix, unfortunately, for now. But there might be a part 2. I will let you know by the time I edit this video. So I'll put something down on the bottom of the screen. I'll let you know by the time I edit this video whether there will be a part 2. But if not, then obviously I'm going to offer to... Well, if the customer doesn't want to do it, then I'm going to offer to buy it off the customer. But I really wouldn't pay that much. I'd probably give them a refund on their MOSFETs. And give them like 50 quid for the console, because at the end of the day I've got to take a risk, and obviously there's money to be made in the power supply and the SSD and stuff like that, but it means sitting on it, and I've got quite a few of those parts lying around. So yeah, I would offer to buy it, but I wouldn't pay that much for it. You would only get around about £120 selling it on eBay, and that's if you're dishonest in the listing. If you actually put in the listing that it's going internal short and you know it's unrepairable, people are not going to pay much for it. And the fact that I would have to get it back to the customer as well, and they live in Ireland. So yeah, does the customer want to sell it me and save all the aggro? Maybe, I don't know, we'll see. But anyway, unfortunately this is going to be a no fix. It looks like the customer has been royally screwed on this one. It is what it is, unfortunately. But that's going to be it for now. Thank you very much for watching. Let me know what you think down in the comments down below. Don't forget to subscribe if you want to see more repair videos. It turns out around about 60% of people who watch these videos are not subscribed. So I would really appreciate it if you do get subscribed and turn on the bell notifications, and that way you don't miss any future videos. If you want to organise a repair, I do go above and beyond. I do try my absolute best to get them working. Be sure to get in touch at www.thecoder.repair, and if you do need to buy parts and supplies for these, then you can buy them from my online store, consolefix.shop. With that being said, thank you very much for watching, and I'll see you all in the next video. Take care, everyone. Bye for now.